I'm sure you've all heard of the billion-dollar mistake, which is nulls. Right? There's many papers on this, that many languages that have support for nulls have introduced this issue of continuously getting null reference exceptions or null pointer exceptions at runtime. With Kotlin, we've taken a different approach. By default, Kotlin is null safe. What does that mean? Let's look at some code. Take the main function. I'm going to create a variable of type message. I'm going to assign null. See that null is highlighted, but I can't assign null. Let's take a string. For example, we'll call it message, and I'll say a message. Now, I print this out, and I say message, and it's all great. And if I call length, it's all good. Because this message is never going to be null. Why? Because we've initialized it. Let's be explicit about this initialization. Let's say string equals message. So now we're saying that this is of type string and it's a message. Now let's remove this and try and write null. It gives an error because in Kotlin, by default, types cannot be null. So that's why we say it's kind of like a null-safe language, because we don't encourage them. And when you declare a variable, it cannot be null. So this means that I am pretty sure that anytime I use message, length will work because I'm never going to invoke it on a null reference. So let's put this back to message, and all is great. But what happens when we want to work with nulls? I mean, there's cases where, for one reason or another, we want to work with nulls. One of the things that we've been talking about quite a bit and we've mentioned is that Kotlin is interoperable with Java. So you take any type in Java that could potentially be null. I call a method that returns a string that could be null. How am I going to do that if Kotlin is null safe? Well, we can actually declare types as nullable. We can declare variables as nullable. And let's take another message, null message. And if we add the question mark to the type, what we're saying is that this variable can now hold a null value. So I can actually do something like null. We can actually do this without having to be explicit on the type also, just letting the compiler infer. So inferred null, and I do null. And you can see that that is saying that this is now a nullable value. Now what happens when we do this? Let's go ahead and do a print line null message dot length. And we can see an error. See that? What's it saying? It's saying only safe or null asserted calls are allowed on a nullable receiver of type string, which essentially means you are going to mess up. How? Let's run and see. We can't, because it's null safe. This is where the compiler is helping us. It's saying you are calling length on a variable that can potentially be null. Now, if I change this to mutable and I write null message equals hello, the compiler says, okay, it's fine, it's good to go, we can run this, fantastic, let's go ahead and run, compile, and all is great. But, this isn't always going to be the case. We don't know if a value is going to be null at compile time. So what happens in these scenarios? So let's put this back to immutable, let's remove this. What do? Well, obviously we can do something like, well, if null message is not null, and then print the actual value. So we can see that now there's no issue. It's saying that the compiler error is gone. We can actually compile this, and we can run it, and it all works. Obviously, because it's null, it's never going to print the value. But we're basically adding the null check. So we go back to square one, which is, hey, you know, I've got some nullable value, and if I have to work with it, I better make sure that it's not null, and so on and so forth. And this can, of course, be problematic, right? Because let's say, for instance, I have a customer in Java. We have this customer in Java over here. So let's go ahead and invoke this. Customer Java. Let's go create an instance of customer Java. And customer Java, now if I do something like print line, customer Java, name, length, there is a potential possibility, and we'll see why the compiler is not complaining now, but we'll cover that later. But there is a potential possibility that customer Java name could be null, and then consequently this could throw an exception. And of course here I'm creating an instance, but let's say that, for instance, I have a function that returns a customer Java, which could potentially be null. Then, you know, there are cases where null exceptions happen. So I have to do kind of like if customer Java is not null, and then, you know, again add this, move this up, and then do something again here like if customer Java name is not null, then actually move this there, right? So what happens, obviously, this is just a compiler warning saying that, well, in this case, it's never going to be because you've just instantiated it. But if this were coming from, for example, a method that we wouldn't know whether that is null, then we wouldn't have this obsolete check here. But you can see that what happens quickly is that I get these like, you know, like a tilted Christmas tree, as they say, also is like multiple if. So what we provide in Kotlin to kind of make this a little less cumbersome is the Elvis operator or the safe operator. So if we come here, I can actually remove this null check, and we get back our little message. And instead of putting that if, I can just put the question mark. So the question mark is saying if the value is not null, then invoke the method length on it. If it is null, then don't do it. So I can run this, I can compile it, compiles, and I run, and it calls null. Now, why is it doing null? Because print line is going to take the null message and it's going to convert it to a string and say this is null. So it's actually printing something, but it's printing null. So by default, it's saying, okay, I'll just do a toString of the actual property, of the actual variable that you're passing in. I'm going to call the toString member function on the type. But this cuts down a lot the boilerplate code that we have to write. So if, for example, a property here was null, we can again add a question mark. Let's see an example of that. I see class service provider, and then the service provider can actually has a function that creates services that potentially returns a service. I'm going to go ahead and create another class service here. That could be of type null, and some default implementation. Now the service class in turn also has a function that could be evaluate. So if we now go ahead here and say, okay, let's go ahead and create an instance of our service provider. And now we're going to call service provider create service. And then on here, we're going to call evaluate. We can see that, again, it's complaining that this could be potentially null. So again, we can add the question mark there. Okay. Now, if we had a function that would return this, which we'll do now, we're going to go and create a function that creates a service provider. And we're going to say that this could actually return a service provider that is of nullable type. So you can now see that now the warning is raised here. So I get a nice little SP question mark create services question mark evaluate and so on and so forth. So we can add as many as we want. And this is obviously better than doing something like if SP is not null, then if creates SP create services is not null, then SP do what have you, evaluate. Multiple indented ifs are replaced with a single line of question mark, question mark, question mark. Now, if we look at this warning over here, we see that there's also another message in the compiler. You can see that it says only safe, which we've already seen, or non-null asserted calls, which is the double exclamation mark. What happens if we use the double exclamation mark? Let's go ahead and do that. Put those two question marks. Now, first thing we see is we got rid of the compiler error. Fantastic. Now let's run it. Remove this stuff as well. Clean this up. Run that. Oh, null pointer exception. So what we're effectively saying here is, hey, you know what, compiler? I know what I'm doing. I'm going to use the double hashbang, which we call it, double exclamation mark, and you know what, just let me do my own thing. And if I get a null reference exception or a null pointer exception at runtime, it's my problem. So we're basically saying to the compiler, stop complaining, it's okay. And the question there is, why would we ever want to do this? So there are certain situations, especially when it comes to interoperability, in which it does make sense for us to have to explicitly tell the compiler, don't worry about this. I know what I'm doing. It's okay. I'll risk running a null pointer exception at runtime. So in summary, in terms of null safety, Kotlin is by default a null safe language. You can actually have types that are explicitly marked as nullable in the sense that they can contain the null value. We can do this by suffixing it with the question mark. The question mark operator also provides us the ability to access members when these are not null. So it saves on having to write boilerplate code with if whatever not null. We can just put the question mark on prefixing the calls, etc. The double hashbang operator provides us a way to access members even if they could potentially be null. So the double hashbang operator, as we just saw, is basically saying to the compiler, you know what, I know what I'm doing, I know that this could potentially be null, but let me go ahead and invoke the member property or function.